Welcome back to another Akeyless Getting Started video. In this video, we're going to talk about using SSH certificates instead of SSH keys. Companies that are scaling their cloud infrastructure quickly take on large numbers of servers and keys. Admins are stuck issuing, revoking, and managing these keys instead of building automation. There are two main problems with them. SSH keys can get lost in the shuffle, and keys that were intended to be temporary stick around on the server even after a developer leaves the company or after a script becomes obsolete. A common solution is using an SSH key management software to rotate keys, provision new ones, and audit locations where the keys are used. But then you still need to manage an inventory of private keys for all machines each user wants access to, and manage an inventory of which public keys are allowed for each machine. Akeyless, using a single sign-on, connects an SSH client to the server using your chosen authentication method while using existing access groups and policies in your environment. But instead of issuing SSH key pairs, Akeyless provides ephemeral SSH certificates to allow access over standard SSH protocol while eliminating the need for public SSH keys on the server side. You can define several SSH certificate authorities. Each CA can sign your SSH public keys with additional parameters like expiration date, principals, extensions, etc. You can sign the certificates with your own private key or generate a new one using Akeyless. So let's go ahead and see how an SSH certificate works with Akeyless. So let's go ahead and get started creating our SSH certificate and seeing how it's used to log into the remote machine. So what we're going to do is first make sure that we either create or have a public and private SSH key created for us. And if you have a Linux or a Mac machine, then you're going to have that already by default on your machine. But if you have a Windows machine, then you're going to have to go ahead and create your own public and private key. So, and I can show you here. Here we have the SSH folder, and you can see I have the private and the public keys all ready to go. The next thing we're going to do is create in Akeyless the RSA key, which is going to be the signing or the certificate authority key to sign the SSH certificate. So we go ahead and run Akeyless create with the name and the type of encryption you want, and we'll do that also from the UI. So let's go ahead and do new encryption key. DFC, we'll call this signing key, just for our purposes, of course. And if you have the various different kinds of delete protection, you have to choose the type that you want, and you can import the key, or you can have Akeyless generated with a customer fragment or without. We're going to go ahead and just click finish and have our signing key created for us. And so the next thing we need to go ahead and do is go ahead and grab the RSA public key information here, the SSH RSA format specifically, and we could do that on the CLI, in the CLI by running this command, or we can simply go ahead into the UI, click on get public RSA key, and here we see the SSH format that we want. Go ahead and click copy, and we can go ahead and we have to now create the key on the remote machine side. So I'm in my remote machine here, in the SSH folder, and I can go ahead and run sudo vi, we'll just call it ca.pub, creates that file for us. And go ahead and paste in, save that file. Okay, and now we have it ready to go. And then the next thing we need to do is go ahead back to the docs here, and we need to add these two lines to our sshd config file in order to make sure that everything's accepted on the server side, on the remote machine side. So if we go back here, run sudo vi sshd config, we'll just go straight to the bottom, add that line, grab this next line, paste that in as well. Save that. And the last thing we're going to go ahead and do here is just restart the SSH service, sudo service SSH restart. Great. And now we're ready to go ahead and create our certificate authority and then issue a certificate. So in order to go ahead and create our certificate authority, we need to go ahead and we'll just copy that command. We'll do this from the CLI this time. We'll go ahead into our local machine. So we're doing something, creating something called an SSH certificate issuer. And the name here will be whatever you want to name it. So we'll just call it SSH cert issuer. And the signing key name is the RSA key we created earlier. So that's signing key. And the allowed users here will allow Ubuntu and root. We only need Ubuntu really, so we'll just erase the root. And the time to live will leave for 300 seconds. So we go ahead and hit enter. And we now have our SSH cert issuer created. We can go back to the UI, hit refresh there, and we have our SSH cert issuer right there, and we can generate an SSH certificate. So now what we need to keep in mind is that until now we've been running the admin tasks of creating the signing key and the certificate issuer and all that. And now we're going to go ahead and show the point of view of a user, where the user will simply generate an SSH certificate or request an SSH certificate in order to log into that remote machine. So we have two options. You can do it from the UI. We can also do it from the CLI. We'll go ahead and grab the issuing a certificate command here. And we'll go ahead into our local machine. We'll run the command Akeyless get SSH certificate. Certificate username is Ubuntu. The issuer name is SSH cert issuer. And the public key file is over here, idrsa.pub. And now we have successfully created the new public key, which is an SSH certificate in essence, called ID_RSA -cert. So now that we have that ready, we can simply go ahead and run the SSH command without any extra data in there. So it's just SSH Ubuntu @ and then the location of the remote machine. And we go ahead and hit enter. We can see that we are now logged into that remote machine. That's the same remote machine. You can see the IP address here, same as the IP address here. So we're now logged into that same machine without any public private key pair, for example, or any other option. Simply an ephemeral SSH certificate was used to log into that remote machine. And that's it for this video. Thanks for watching.